In today's notes, we're going to be taking a look at non-linear regressions. And it says at the top, just reading, sometimes your scatter plot data will show a trend that is non-linear. If you sketch the curve or best fit, it may be exponential or quadratic. Last class, we took a look at residuals. And the residuals told us whether the fit was a linear fit or a non-linear fit. So a non-linear, the residuals or the residual plot was one that had a pattern. It was not random or had an evenly dispersion of points above and below the x-axis. Okay, so those types of plots, okay, where the residual has a pattern, could be something that was exponential or quadratic. So remember your linear functions, okay, down to these bullets here. This is what the graph looks like. Quadratic was the parabola, or the U-shaped curve, and then exponential was like the curved L. So instead of a linear, today we're going to take a look at quadratic and exponential curves to model the data. We still, going back up into the steps, we still enter the values of x into L1 and y into L2. That does not change. And then we look at the scatter plot and then decide which function fits the data best. And then we're going to calculate different regressions. Okay, so 4 is the linear regression on the calculator. In the list, number 5 is the quadratic regression, and 0 is the exponential. And we'll take a look at both the quadratic and an exponential regression on the back. So number 1, we're just going to look at the scatter plots below and determine, based on the scatter plot, which type of function will best model the data. So this data here, okay, would be a linear data plot. We don't necessarily see a pattern. To the right, the pattern looks like the exponential curve. So an exponential model would be best. The next row, okay, I don't see that pattern, so we could look at a line of best fit or a linear model. Here, the pattern is U-shaped. So that parabola is a quadratic function. And then last, I don't see a pattern, so that would be linear. There would be our line of best fit. As I said, on the back, we're actually going to run some regressions. Okay. So about a year ago, number 1, Joey watched an online video of a band and noticed that it had been viewed only 843 times. A month later, Jody noticed that the band's video had 1,708 views. Joey made the table below to keep track of his cumulative number of views the video was getting online. So in this table, okay, the total number of views, you see, all depends on the number of months. So our months is going to be our X or list 1, and our total number of views is going to be our Y or list 2. In the table, you see that Joey forgot to record the total viewings for that second month. So we're not going to put that into the calculator. So let's take a minute, open up the graphing calculator, and put in your list. And we're not going to put in the x value of 2. So I'm going to reset the calculator. I'm going to bring it over. I'm going to go to, let's try to get rid of the, all right. Let's go to Stat, Edit, List 1, List 2. So I have 0, 1, not going to put in the 2, so 3, 4, 5, 6. So over into the next column, it was 0, 843. 1 is 1,708. 3 was 7,124. 4 is 14,684. And then 29,787. And then 6, 62,381. Okay, so now I want to see the scatter plot for this. So I go to second stat plot, number 1. I need to turn the plot on and then go down. And it's on scatter plot and it's on list 1 and list 2. So now I'm going to hit graph. I don't see it, but if I go to zoom and then down to the stat, zoom stat, which is number 9, you can either press 9 or hit enter. I can see my scatter plot. Now that to me, okay, looks like there's a pattern, and the pattern looks to be exponential. Okay, so let's sketch that. Take another quick glance. 1, 2, 3, 4, 5. So when I write a regression equation, I'm going to run an exponential regression. So now that the data is in the calculator, we're going to go to Stat, Calculate, Exponential Regression. We have to scroll down to see it. Right here, so 0. Hit enter. Hit enter again. And there is our A value and B value. So take a minute to copy those down from your calculator. To write the equation, it says we're going to round to the nearest hundredth. So the A value, the hundredths place, tens, hundredths, tens, hundredths. So we get y equals, remember exponential is a times b to the x. So 836.47, as the 0 is going to keep the 7 the same, times 2.0. The 7 is going to bump that up to a 5, and then exponential is raised to the x. The x needs to be in the exponent. So here's our equation. As shown in the table, Joey forgot to record the number of views after the second, as we saw in the table. Use the equation from part A to estimate the number of full views of the online video that Joey forgot. So Joey forgot the x value of 2. So we're going to plug in and do the math. So 836.47 times 2.05 to the second power. So on the calculator, 2.05, whoops, 2.05 raised to the second, then times 836.47 36.47. There's our answer. The number of full views. So that's rounded to the nearest whole number. So let's write down the whole decimal. And it's good to do that on your state test so they can see that you just had a rounding error if you make an error at all. So it's the nearest whole number. So to the right is a 2. It's not going to bump it up. So it's about 3,515 views. All right, last one. A kicker punts a football 11 times at the same velocity, but at different angles. The table below shows the distance the football traveled when kicked at each angle. So we can't calculate the distance until they kick it. So this is our X, or list 1, and this is Y, which is list 2. So let's take a minute to enter the data. Remember, to get rid of the data in each, you go over the L1, L2, and hit clear. Okay, so take a minute to enter the numbers. Was 60.83. You're probably much quicker using your calculator than I am with the board calculator. So 3663.21, 3965.07, 42, and then 66.19, 45, 66.56, 48, and then 66.20, 65.11, and then 63.32, and then 60.85, and the last one, 57.73. Okay, so let's see the scatter plot. So just to double check, second, y equals, the plot is on. I see the scatter plot graph. Remember to see the graph, do zoom 9. Okay, and that to me looks like a parabola, which would be a quadratic regression. So part A says, what model would you use to describe the relationship? And explain why you chose this model. So before I do that though, I'm actually going to do part B to get the equation. So I go to Stat, Calc, and then run the quadratic, which is number 5, and then hit Enter. And there's the A value, B value, and C value. So remember, a quadratic equation in standard form is y equals ax squared plus bx plus c. So I'm going to write the a, b, and c down. So take a minute to copy those down from your calculator. We're rounding to the nearest hundredth. So it's going to be y equals the a value The 9 will bump that up to a 4. So negative 0.04 x squared. And then plus the b, the 8's going to bump that up. So 3.53x. And then minus 12.9. And you actually have to put in the 0 even though it stays, because it has to be to the hundreds place. And there's the equation that models. So once again, the model that we chose is a quadratic. And this is because the shape of the scatter plot was a parabola. And instead of saying it's a parabola, you can just state that it's a U-shaped curve. Part C. Based on this model, how far would you expect a football to travel if it was kicked at an angle of 47 degrees? So that means if x is 47, find y. So when we plug it in, y equals negative 0.04 using our equation, and then 47 squared plus 3.53 times 47 minus 12.90. So in doing the math, it doesn't say to round. So if we plug it in, negative 0.04 times 47 squared plus 3.53 times 47, and then minus 12.9. It's 64.65. And that's in terms of how far we are in yards. So the last thing I'll show you before we stop the video is, in seeing our scatter plot, how to get the actual regression on the grid as we did with the linear. And you could do the same for exponential. It's the same for linear. To get it to show, you have to type it in. So negative, this is our prediction curve, 0.04 x squared plus 3.53x minus 12.9 graph. Okay, so there's the prediction line for that data with the actual points of the scatter plot.